Today I'm gonna do some Unreal 5 dev. I have some ideas to get implemented here. We're primarily going to be looking at the Starfield Fade Out. So as stars approach the edges of the field that we render, we want them to basically increase their alpha. So it'll be a multiplier here. So we need to figure out the distance to the player camera.
So there's in terms of the blend mode, we just want to switch the blend mode so that it's must rather than opaque. Okay, so the next thing we want to do is go to content browser, go to materials and textures, and create a new.
Just gonna quickly find how he fetches the camera position. Here it is.
Function input.
Camera position. World position. Use. No. Distance. Between these two. This is our true distance, the camera. This value is going to be our units, like our one-to-one units. We're just going to say 35. So we have we have to figure out the range that we want to fade it in, right? So we need a denominator that would be this times 35. That means that we'll fade out over the last 5 blocks of space. And then, so this is going to give us the min distance that we want to start fading at. And this is going to give us the max distance where it's completely faded out. So the first thing we want to do is subtract the minimum distance from this, right? And then if that is, take the max of that and 0, right? So what does this do? This is our true distance in units. This value is going to feed in our actual unit distance per major unit. In this case, it'd be like 80 million or whatever, right? No, this is the distance between stars in the actual star field, not 80 million. So if this was, say, 100,000, then this would be 3.5 million would be our beginning of fade out range. And then we're going to subtract the actual distance from that, and whatever we have left over this minus from 1 will then get multiplied by our opacity mask and fed back into the opacity. And then we have to go change our logic for generating the particle color to include the distance increment here, which should be pretty simple. And then we can go test. I think that makes sense. Content drawer, Starfield, randomizer functions. Looking for the adapted Niagara arrays function where we generate the color. This. Okay, here it is right here. Okay, so this needs to be manually set. Or I guess it could be how do I set a variable in the game instance? 5. Starfield distance increment, make this a float. It should really be, yeah, float's fine. Increment. Project settings. Maps and modes. Game instance class drop down box. Okay. Key game instance cast to, okay, I see. And then over here we can do to universe and game instance. Here, here. Yep. Starfield distance increment. Feed that into here. Save that, compile, game instance, compile, make a default. We'll do 100,000 as the default. And then, do I actually, is there a game? No, maybe we have to pass it in this way. Okay, so we do that, and then compiles. Now, we need to also update our Starfield blueprint here to oh no, this is shit. Wasn't this working with set relative location? Thought. Maybe not. Game instance cast to universe sim game instance distance increment. Okay, now everybody's on the same page. Now we have to figure out this. Let's go ahead and connect it back to the way it was for the moment. Try to run it and see what happens. Okay, we want to change our distance increment to allow us to move faster so that we can test it better. That's here. Yeah, this is the full thing. So let's do 1-to-1. All right, 1-to-1 motion. The size is also obviously too big right now, but does seem to be fading the stars in, which is what we wanted. The scale is too fast. We can change that pretty easily. So in order to change that, it's just a matter of changing these numbers here. We'll do 20, we'll do half and half. Fades out over half of the distance, and then save that. Go to Starfield. So now instead of fading out over a quarter of the distance, it'll fade in over half the distance of the total Starfield. And then we'll go to here and change the size to something that makes a little bit more sense for the distance we're currently using. Actually, game instance, we can turn this back up to a milli. Save and compile that, and then we can come down here and change this to maybe like 10,000. seems to work pretty well. Alright, and then how do I do this? If I go back to 100,000, what happens? Okay, another thing we need to do here is change the white multiplier, alpha 0.1, maybe 0.2. Save that, it'll take a while. I might do like 30-10. I should have done this before. Okay, so I can close down this game instance. I know how that's working. Seems like my math just worked out of the box, which is rare. Usually I have to bash face on it. Okay. Let's run it like this. Yeah, those colors look a little bit better. Still have color variance, it's just and these stars are way too big relative to the space that they occupy. So let's go ahead and go here and up this to 1,000,000. Save it, compile it. See, what I don't understand is something's up because I should see the same amount of stars based on the math. So let's see, this is pulling this value from the alpha, multiplying by 30, doing all the things, BP Starfield. This is getting the game instance value, getting the Starfield distance increment, which is 1,000,000, feeding into the distance scalar, new location logic, and then Maybe it's like the relative size. Okay, it's probably the relative size, so let's try that. So we upped that by an order of magnitude. If I up this by an order of magnitude, do I see the same thing? Yes. So it's actually the size in conjunction making it invisible. So I don't want it quite that big because they're not like this. The width of those stars relative to their distance between the stars is definitely out of whack. What if I did 30K? So I think that is working. What do I want to do next? So I'm just thinking we need to start figuring out dynamic updates to the data for it. In the meantime, I want to go center coordinates. Oh yeah, I did want to try this. Save, compile. Although it was working pretty good with it just on the event loop of the okay, so that one doesn't work. Go back here. Here. Save that, change this value to be a lot bigger. Try 10 million. So now we should travel as if there were 10 million units between each star. I mean, roughly, give or take. There's randomization involved, but that's the base unit getting randomized. So it should take substantially longer to transit. Braking. So get close to a star. Clearly the bounds is used as a box, which is why these things fade out as I face them, because the corners are actually further away. Easier to calculate the bounds of a box than a sphere, so I can identify with the reason that they would have done it that way. It's the same reason my Starfield is a cube instead of a sphere. So I do like the fade-in effect. It works quite well, and I imagine with a skybox with nebulas and such, it would also work very well. Which is also going to have to be a dynamic component of this whole process. So that's working. Let's try it with the full scale. It's going to take a long time to travel, but I also want to try P-Starfield, MT-Star Particle. I also want to try Luminosity Multiplier. 20. Save that. Okay, let's give this a shot. Brighter stars, further away. Takes us longer to get to anything. A lot longer. Okay, so this is closer to the actual speed you would move in the interstellar travel. So this green star is relatively close. Maintain our heading towards this green star here. Also looking in the background for stars fading in, because that's really what we're testing. But with the way it's rigged, by the time you go from one star to another star, you should have the edge stars loading back in. By now we would have swapped out the like actual star model and whatnot. So let's see. Go from here, pick a star. I want to travel to this star. We're going to need logs of the Starfield location, the player location, the increment we're in, the galactic coordinate, because we're going to have to update as we cross. So like as we cross 80 million from origin, we need to update the star map. Now the flickering issues are clearly a problem. If I wonder if I could window project settings, aliasing. Try different forms of anti-aliasing. Okay, we get the idea. I want to go ahead and change this a bit, make it a little bit more easy to test, but we know that we can reduce it. Alright, come on, come on, come on. Okay, there we go. Accelerating. Alright, I made it back to this green star that we went to. I'm just gassing it. I mean, I actually think this is like almost there as far as the appearance goes. Go to this green star just for fun. Way off in the distance there, and then after that I'm going to start looking at dynamic updates for the Starfield. Reorigining and dynamic updates, which will probably be quite a challenge. We have stars popping into existence in the background very nicely. All right. As far as I'm concerned, that's a success. Okay, so now the fun part. We need to be able to do a few things. And I'm thinking about the things that we need to be able to do. First, let's get all this logic neatly packed. Okay, great. And then what we actually need to be doing is okay. Oops. Okay, if it's less than this times -1, flip it. If it's less than this, if it's less than this, it's less than this. Less than, greater than. So basically, when the user exceeds the bounds of the scene unit to universe unit, we have to reorigin the environment to the flip of whatever it is, and we have to update the Starfield data with new data on whatever axis they crossed, and also subtract data from the back end of it. In fact, the data that we fetch, like, we're gonna have to change probably some of the way we do that, but we'll cross that bridge when we get to it. So branch sequence Okay, so first two are X, then Y, then Z, so... Okay. Oops. Scan. Alright, here's one. There's two. It's my little to-dos, sort of. Now I need to look at internet information to figure out how to do what I want to do. 839009. UE5 reorigin. UE5 reorigin. Origin rebasing. Origin rebasing. Origin rebasing, origin rebasing. Reset. Set world origin location. Hey, that's nice. Alright. So, here's our axe. If we overflowed on the negative, wait, is it just the same? It's the same. Because I can just take this, multiply it by -1 to flip it, version. I gotta get a paint going to figure this out. Don't save. So let's look at only x-axis. And what we want to do, so figure out the math of it. Alright, say we're here. So we're right here, and we're moving towards this side. When I hit this line, which would be, in our case, 80 million, but we'll just say 8. Or 10. 10, motherfucker, that's a 10. Okay, so when we hit 10, we want to reset the world of origin to where we're then at negative 10. Which means the world origin needs to move the world origin distance to the right. We're not flipping it. We just add. And then, okay, so it's not exactly as simple as I thought. Okay, if we're less, we need to subtract. Take this value, minus plus this. If it's less than, multiplication vector. There's one. Here's 2. Yeah. Default to that. Adaptive Niagara arrays is going to take the current coordinate. Then over here, we need to do the same thing. Set current coordinate. Coordinate. Struct. Alright, there's one example. This would be subtraction, so in the case of us rebasing because we were less than, we will subtract. More than, we will add. And then just for the moment, get rid of the player offset input. Wait, never mind, I'm using it. Functions, private functions, we want it inverse coordinates x put integer output nothing, big game instance cast to universe and game instance. Offset looks good. Get current coordinate split, set, current, coordinate, split. Okay, and this way we can do all the logic. So here we want min coordinate range, max coordinate range, negative 499, positive 499, pile. Okay. So plus the offset. Then greater than range. We have to handle the universe offsetting as well, the universe coordinate offsetting as well. So we do this. If this is less than it's less than the min, it's greater than the max. We'll call this axis float. Alright, so the first thing we want to do is set this value to this. Right? It's the first thing we do. Oops. Pull these down. We set this to this, because that's going to let us do some other things with it. The updated axis is less than the min coordinate range just on a sequence here. Yep. Actually, don't want a sequence. I don't want to execute these if I don't have to, so we'll do true here and false to here. And our conditions are going to be alright, so we have to update the axis. So basically what we're trying to figure out is the translation between the game space coordinates and making that map one-to-one with our universal coordinates that we use for our randomization. Set this to, since we're only operating on x-axis with this function, we're going to copy it for the other axes. We don't have to worry about I guess these could be integers, huh? We don't have to worry about the other axes for the moment. Clear this, delete this, pass this here, pass this here. This goes here, then here. Alright. So the idea here being that we may have to do logic to also update the universe location. Okay. It's greater than the max or less than the min. So now we need Notepad, some Notepad math. So let's assume that we have past negative 499, we're at negative 500, right? That's our current value. We've passed our true statement. So if I were to simply add or subtract, if I subtract negative 499 we would be left at 1, which would be wrong. Times 2. Negative 500 minus negative 2. Clear. 499 times 2 is 998. Negative 500 plus 998. 498. Which seems to map properly with my understanding of what it should be. Ooh, thundery. Looks good. And then if I was positive, it would be positive 500 minus negative 498, which is what the equivalent would be. So I think this is our logic. It's this is going to equal this minus this times 2. And we decrement the universe coordinate by 1. Something like that. Shit, it's actually max. The other way will be min. And then none of this stuff would change for an x-axis call. So in this case, we would be incrementing the max. That makes this the min of the max. And minus get rid of this, and then this becomes 2 times the max, and this is the minor. And then after both these are done, we terminate. We're done. We've updated the world coordinates for the x-axis, I think, at that point. So I'm gonna organize this real quick, and then I need to go make some lunch because I'm hungry. I think this is some good progress, though. Seems good. I'm just going to move everything over a smidge so that we can pull this guy right to here. Pull this in. Alright, save file. Oops. This also has to connect here. Because these conditionals are just edge cases. Like, all this logic doesn't happen most of the time, because most of the time you're just going to subtract, and that's it. You're good. It only matters when you pass thresholds, and you need to cascade up into the next larger... Get rid of this. This was less than, so this will be -1. This is greater than, and it'll be 1. Boom. Alright, there we go. Alright, save file. I'm gonna go make lunch. I might be back later on today doing some more on this.